In this video, we are going to discuss about Boolean difference method. This is one of the subtopic of automatic test pattern generation. Here we are going to generate the test pattern based on the output expression, output Boolean expressions. So suppose if the good output of f is 1, definitely the faulty output of f is equal to 0, right? So the both are different, so I can write f XOR f of a equal to 0 is equal to 1. So from the Shannon's expansion, so this is a 2:1 mux. So if the a value 0 means f of a of 0 is selected. If a gets stuck, it's equal to 0 is selected. If a is equal to 1 means f of a equal to 1 is gets selected. That is the input flow through the output, right? So I can write f is equal to a bar because a is 0 now. F of a equal to 0 gets selected. If a is 1 means f of a equal to 1 is selected. So you substitute this this second equation in the first equation, you will get this one, right? So again I can solve the because a XOR b is equal to a b bar plus b a bar. So from this equation I can solve it like this, right? So better you can bring this f of a equal to 0 XOR f of a bar, bring it inside. So anything if it is the same value means that is 0, right? A XOR a, what is a XOR a bar plus a bar. So there is nothing but a bar, that is equal to 0. So this whole term get cancelled out and you will get a f of a XOR f of a equal to 0 equal to 1. Okay, so this is nothing but this term is nothing but Boolean difference of f with respect to a. So what is the now df of a, differentiation of f divided by a is nothing but f of a equal to 1 XOR f of a equal to 0, right? So we know that a equal to 1 and a equal to 0 is different, therefore the a is sensitized to the output of f. So this method is not used practically because we need only one test vector, which but not all the test pattern in order to find the fault. Therefore the Boolean expression is not always available, especially in the synthesized circuits. It makes the automatic test pattern algorithm difficult. So let us discuss one example problem. Okay, so this is your circuit, and a, b, c, d are your primary inputs, and c gets stuck at 0. Okay, so if it is stuck at 0, I have to find the dou f df divided by dc, right? So that is equal to f of c equal to 0 XOR f of c equal to 1. So if the if c is stuck at 0 means anything multiplication with 0 is 0, right? So here also you have 1, so this is d. So f is equal to 0 plus d, so you will get f of c of 0 is equal to d. Similar way, if I substitute c is equal to 1, this becomes 0, so this is 0 now. This is a plus b, right? This is a plus b, so you will get anything multiplied with 1, you will get a plus b. So f of c of f c is equal to 1 is equal to a plus b. So you substitute here. So you substitute here, and you can apply the formula like d of a is equal to d a bar plus a d bar. Okay, so if you solve this one, you will get d, this I can write it as a bar b bar, right? So if I solve this one, I will get d a bar b bar plus d bar a plus a d bar b, right? So you rearrange this equation. If I rearrange this equation, a bar b bar d plus a d bar plus b d bar, right? So the test vectors are now, you can see, since c is stuck at 0, since c is stuck at 0, you have to multiply with c. Okay, so if c is stuck at 1, so you have to multiply with c bar. So you are multiplying the c with this equation, and you can write how to write this is 0 0 1 0 0 0 1 0, sorry, 0 0 1 1, this is 0 0 1 1, and this is 1. X b value I don't know, so this is b is x, c is 1, d bar is 0. Likewise x a is not available, so x 1 1 0. So these are the three vectors. So 1x 1 0, I can write it as 1 0 1 1, sorry, 1 0 and 1 1 1 0. Okay, so totally you can see nearly 5 test vectors are there, which will identify the stuck at 0 fault at the C. So I hope this video will be useful for you. Thank you for listening to the video.